Breaking news, a new company by the name of Aurora Industries had just become with a drone, and it's called the Telodrone. They're going to be launching this to Mars. And I'm going to be interviewing their team on how they came up with this groundbreaking technology and how it works. I'll keep you informed.
Hi, my name is Seth Price, and I'm the project manager for Aurora Industries. We have a new revolutionary invention. This is going to be the second ever Martian drone. It is the Telodrone, and here it is, right here. Thank you, sir. I love you. This is our Martian drone. Please hold the applause. Sir, hold the questions. This is our new Telodrone, and we will be using it to explore Mars. This will be a research and development program, and it will definitely help our company and its production throughout the solar system.
So you're saying you're going to launch this drone into space?
Yes, we will. We will be launching this drone into space, and it will be doing all of its operations on Mars.
Yeah.
Thank you.
Hey, excuse me, sir. Is this the new drone for Aurora Industries?
Why, yes, this is the new Telodrone for Aurora Industries. It's going to Mars.
Oh, how does it work? Is this code?
That's code, yes. So this drone is able to be coded using block code, which is really easy and safe to use. Now, with this code, you can make it do several actions, like fly straight up after takeoff. It has automatic takeoff.
Wow.
Fly forward a designated amount of inches or centimeters, backwards, left and right. It can turn on its own axis. It can flip always forward, back, left, and right. And it can even curve using the drone blocks.
So how did these little blocks make the drone do all that?
Well, first you put in the takeoff method. Then you put on whatever method you want. For us, we're using the fly up so that we can get some height while we're testing so we don't hit the ground for safety measures. And then after that, you can add on whatever code you want under it. And then when you're done adding code under it, you add the land function, which lets the drone automatically land using its AI.
Awesome. Thank you. Hey, do you think I could touch it for,
Yeah, let me just hand it.
Hey!
Oh, wait.
Oh.
Wait, that's dangerous. Back away from the drone. Sir, back away from the drone. I'm the safety and security manager for Aurora Industries.
Oh, what could this drone do to me?
I'm certified. You see these? These are propellers. They're dangerous. They spin really fast.
They don't look that fast.
They don't look that fast now, but when the drone is on, the drone is on. And then if they spin fast enough, they will cut your hand open. It's very dangerous. Very dangerous.
Hello, sir. So how does this drone work?
So our drone, it offsets the propellers to move forward and backwards. It also ups the lift by making the motor speed faster, or when it wants to go down, it makes it lower on the motor speed. Same thing when it's going left or right, it offsets the motors with more power or less power on each side of the So like this, right here, it is offsetting the front to go forward, and then when it wants to stop it, it goes back. And then it stops its momentum, and then lowering down by using the propeller speed.
Fascinating. Thank you.
Hi, I'm Justin. I'm the lead coder for Aurora Industries, and for the next 4 weeks, we will be using a program called Drone Blocks that we're using on our phone in order to control the drone for our individual projects. All right, so this is a pulled-up image of the actual site. So we have our actual codes, which every single one of them needs to start with a takeoff and end with a land. That's kind of the start and end function. And then on the right here are all the tabs. So when you open a tab, it has different code blocks, and they're all pre-coded, similar to the drive train stuff that we did before, where it's pre-set up functions where all we have to do is input numbers like that 20 in order to actually control our project. Alright, so our drone has 4 forces acting upon it, those being in pairs. So there's going to be drag and thrust, and lift and weight. So the first pair is thrust and drag. So on our drone specifically, all of the thrusters are pointing straight upwards, right? So when it's going up, it's obviously going to feel the air resistance push down as it goes up, and thus the rotors will need to spin faster in order to counteract that. The next one is lift and weight. So if our drone is too heavy, the airfoils inside of the propellers cannot generate enough lift for it to be able to get off the ground. And obviously on Mars, we'll have a weaker atmosphere, and thus the motors will have to spin faster on Mars in order to generate the same amount of lift as it would need to take off on Earth.